All right, so we're gonna do a little bit of review stuff, a little bit of new stuff. Still not really getting in anything super. I think what's the tough stuff, I don't think I'm spending a ton of time on it anyway. I mean, we could spend a week on it. It would still be tough to pick up. So I'm gonna it'll still be quizzed, but I'm not gonna make it a big part of the quiz. So those of you that think you can put some time in and learn it, you can do that on your own. The rest of you just make sure you focus on what I spend the most time. And none of that I don't think is worth. You have an exit ticket at the end of today. I will tell you exactly what you need to know. The stuff that we do is actually even harder than the exit ticket. So the exit ticket is even easier than what we do. So if you get what we do today, you should be fine on the exit ticket at the end of class. This is still, I'm just kind of touching on this. We won't get to that lesson for a little while. I'm trying to give you little pieces, but that we've done. I said you have got to know how to graph this equation or that line, which is the same as what we do in the second part. And then this is the other one I said you have to have memorized. You get those two down, and you can probably figure out the other ones, especially because once we get to that lesson, you'll see them, the other ones also. With that in mind, who am I going to call? Gilberto. Should be in your notes. So if you don't have note, oh, where's your note? If they're in your book and turn to where would you have? This was not a lesson in the book, so where would you have notes on something that wasn't even a lesson in the book? You have a notebook, or you just write everything? Well, this wasn't a specific lesson, so it's going to be kind of hard to find, probably, but we'll see if you can get it from memory. Oh, I know you please. So we don't need in class again. I've had that up forever. Put it on the front door. It won't spill in the bag. Yeah, I did it until somebody finally spilled it and it got crushed in, and then that's when I stopped. Um, what would that line look like? Y equals X. We're just gonna graph because this is just graphing a line, not geometry. It's something you did in algebra, really before algebra, even when you just learned how to graph a line. That's the line to graph. So I showed you in class, if this helps. Well, it's really this line in y equals mx plus b formula. Know kind of what the parts of that format are. You might be able to figure it out. Tell me how to do it if you don't know exactly what it looks like. You have to know that line. This is on Gilbert. Again, I am calling on people on a regular basis to add to my list. People that have not been working, but that are probably sitting there and telling, if their parents are engaged, that are telling their parents that, oh, the class is just too hard. It's just too hard. That's not true. Kids are sitting here not working and then telling your parents lies and they think you're working. It's not that hard a class to pass. Hard to get A or B, but if you come in and put in the effort, especially if you come in and do well, you kind of have to do the retakes to struggle, but you do the retakes. I don't have anybody that comes in and does retakes on a regular basis that does not pass it. No. What do you think? Let me ask you this question, because the other one you need to know is x equals a number. What would that one? Yeah, that's a problem. So collecting evidence to prove to your parents that you're not doing it. That's how I do that. Let's see. I know some of you know it, so I'm less concerned about that. I see somebody frantically looking for the call now. Nathan, looking is fine. I'm fine with it. I'd love to get your call home. If you're putting some effort into it, again, I want you to find it. I'll kind of help you along if you do that. But yeah, when there's like you don't have any notes to even look through and you have no idea how to do it, that's an issue. So, do you have any guesses at it? What do you think it might? Say it again. Well, it's y. So when you say y equals the slope, so y equals mx plus b is this formula. So I'm not sure exactly where you're going with that. So let's write this. This is slope intercept form, which I can change this very simple equation into that format. So 1 is that, 0 is that. So now tell me if that helps you. Like try to clarify what you're saying. What would this, so again, I have a graph, I have an X and Y axis. Y, it's my X, and I'm going to graph a line. I'm going to graph that line on that graph. What would it look like? Like you can just visually describe how, like I'll give you 3 options if this helps. So that would be this. So that is one of the ones you need to memorize. So just keep them straight now. X equals a number is straight up and down. Vertical, straight up and down. This one, so let's talk about that one. If X equals a number is straight up and down, just intuitive. We haven't even practiced this lesson a whole lot yet. Troy, you're good with intuition. Hey, this is what frustrates me back. You're good. You're way better at stuff than you think. If X equals a number in the graph straight up and down, what would Y equals a number maybe be? Yeah, that's it. That's why I say if you just memorize these 2, the other ones are just kind of opposite. So if X equals a number straight up and down, well, Y equals a number straight left and right. Hopefully you know what the x-axis looks like. You just graph the x-axis. The y-axis is the y-axis. Those are labeled. We're looking at those. So now getting to this, Z, did you think you knew this one? Your hand up. Z, then what do you think this crap? Doesn't matter, I'm still calling you. So we just said X is straight up and down, Y is straight left and right. We're probably not going to be one of those 2. So what was the other one we did? Y equals X. What's the other option? It's not straight. Yeah, that's all you got to do is show me visual. It's dot. Is that what you're saying? Do you know the word? Not vertical. So just diagonal. Diagonal. Yes. Diagonal. So it is a line like that. That is Y equals X. Memorize that one. But again, if you and that's exactly how we get it. Is we have a slope of 1. Because slope is 1 and it goes through 0, 0. The y-intercept is 0. I kind of missed it a little bit, but it goes through. Oh, my board's off. So it goes through 0, 0. That's how you graph it really from slope intercept form. If you really just memorize this one, you can almost figure out all the other ones from that in a way. The one exception is you might get confused about y equals x versus y equals negative x if you haven't memorized this one. So that is y equals x. We'll come back and we'll do part 2 in a minute. So if I memorize it that straight up and down, and then intuitively say, okay, well then y is probably straight left and right. If I memorize this is diagonal in that direction, what would, who am I going to call him? Catherine. What would maybe y equals negative x looks like? So instead of y equals x, what's y equals negative x maybe look like? Well, just let's talk intuition right now, because that's not one I told you to memorize. So I'm not as worried about you having that one. But if I know, like I don't even have to think about it. And as soon as I see that, I know that's the line, that red line. But now I say, okay, well, I want you to tell me what y equals negative x looks like. So it's similar, right? Similar to this, but I just put a negative in it. What would maybe that look like? How could I take that and maybe create a line that has some of the same traits, but it's not the same? It's got to be a different line, but the same. It literally, that's what we say this means, really. If you also just remember that, we say the negative sign flips something. So that kind of would help you remember too. So if I just flip the x, I'm kind of flipping the diagonal line. I had never even thought about that. So that is y equals negative. So memorize this one straight up and down. Memorize this one, red line. And then if you put a negative in front of it, you are really just flipping them. That's what a negative in front of a variable means. It means you flip. Well, don't think it's positive. It just means flipping. Think of the negative as flipping. Because it could start negative and flip to positive, or it could start positive and flip to negative. So and now you know all of the lines just by memorizing really two of them. So now for the last part, we'll do two and we'll actually do the reflection. If you want to come up with the rule, and we've done this before, so I'm going to do it fast and we will get to the lesson eventually. We said we're going to take an actual point. If there's a rule, then that means it doesn't matter what point we start with, every point's going to follow the same rule. So if they're asking us for a rule, every point's going to follow the same rule. So I'm just going to use an actual point. My board's not cooperating super well, so oh, that's pretty good. So if I put it there, we'll say that's 2, 1. So I'm starting at 2, 1. So I'll write it really small. So that's the point I always choose. You'll have graph paper for anything I do for sure. And I'm pretty sure on the EOC you'll have graph paper. So we said from there, I've already drawn in the line of reflection, I go diagonally straight at the line of reflection. I have to go perpendicular, that's why I'm going diagonal toward it. We would count one diagonal, and again, it'll be easy when you have graph paper, and then another diagonal. So I basically go to the exact opposite side, and then I would write that ordered pair, the actual numbers. And then I say, okay, well, what happened to my numbers? It went from that number to that number. So Jason, what happened?
It just flipped stuff.
Yeah. Did I flip any signs? Did I make anything a different sign? No. I just flipped spots, right? So the X became the end number, the Y became the beginning number, which means I just moved them one to something. That's your again. Might be multiple choice. They might make you come up with it. I don't know what the EOC is going to do, but you can use actual numbers for all of the rotation reflection stuff. Jackson. All right. So really quickly, we'll wrap it up. You need to be able to pull the slope out, certainly the slope of any equation. Well, these two equations. This is slope-intercept form. Y equals mx plus b, like I wrote up there. Which one is the slope? Just anybody can say this. Which one's the slope? The one with the x, 10 over 9. It's not the first number. It is the number being multiplied times x. If you need to think of it as the number with the x, then think of it as, but they're technically being multiplied together. So the m is 10 over 9. So then the y-intercept, which is the b part, I'm just going to kind of wrap up, is the 1. So again, it's not about where they are. It's about which one is with the x, and then which one is just a number by itself. In this, that's why the 0 was the y-intercept, is because it was all by itself. It wasn't with the x. This is point slope form. I had you memorize that, although we still haven't really used it. We kind of used it today, but we didn't really need to. So you will see this. I forget which lesson it's in, but so if slope intercept form gives me the slope and the y-intercept, what do you think point slope form gives me, Jael? What's called point slope form. Gives us the slope, right? But what else is it going to give me? Another thing in the name. Point. Gives you a point. in the equation itself. It's giving you a point that is on this line. So here's how we find out what that point is. Sometimes you will actually use a point, like you'll see when you're in the Excel. Sometimes they give you a point, and you can use that to create the line. This X1 and Y1 are the point. So whatever is being subtracted or added on is the point.
Is that negative or minus?
That's what we have to figure out. So here's the only tricky part. Because you'll notice subtraction is in both parts of the actual formula, right? When I just have that was formula. So that is subtraction. That's big subtraction. That's subtraction. That's the formula, is subtraction. But if you'll notice when they give us the equation, we have subtraction here, but then we have plus there. So what that's telling me is I'm going to have one positive number and one negative number for my X and my Y. The tricky thing is it's kind of the opposite sometimes of our intuition. So here's how I'll tell you, if you can't, like if this doesn't work perfectly, then just memorize it. But drive me crazy. So this is the formula, right? Y subtract Y1. That's part of the formula. So this is part of the formula. So what is my Y1 value then? Just 4, just positive 4. Perfect. So my Y value is just 4. So what do you think my X value is then if it says plus 3? So Y subtract 4 means my Y is positive or positive 4. What does X plus 3 mean my X value? Yeah, it's opposite. Because remember what happens when we have X, I don't know why I wrote 2. X subtract negative 3, we said, becomes X plus 3. Subtracting a negative becomes addition. That's how we got here. So that's actually, so that is a point on the line. So I'm going to kind of do it in a different order than I did it in the other class because it kind of goes with this last one. What is, did I already do, what is a line? And we did the points of, well, no, I mean like today. I say, what is a line? Yeah. So what is a line? That means for what has a slope. What is a line? By one A, what my favorite. We get so caught up in math, solving problems, learning formulas that we forget some of the most basic stuff, which helps you. Understanding the basics helps you down the road. What's the line? I mean, yeah, a line is 180 degrees, but what is a line? That's going way past, that's traits of a line. What is a line?
And ongoing,
Let's go on forever.
yeah, in the graph. Anyway.
Oh, graph. Think about it. It's normally on a
Oh,
graph,
okay.
right? What's a graph made up of? But the grid lines aren't real. That's just to help you put stuff in the right spot.
Yeah, it's the word.
So Shania, I'm going to go to you before I say what I'm just going to say. So every line is really just a bunch of X and Y points, right? Because that's how we take a point off of it. If you have a line on the graph, I could pick a point and write the X and the Y. It's because every line is just an infinite number of points. It's not one solid thing. It just so happens that those points all follow the same pattern, which is what makes them line up. And then, like I said, there's so many of them that they get closer and closer and closer together, and they look solid. So here's my next question then. I'll just say 1,000. So if you pick a point from a line, and you have an equation for that line, like we have, so let's say we graphed this line, and we picked a point from it. that point will make the equation true. It'll make the left side equal the right side. Every point on the line makes the left side equal the right side, because really that's how you get the line. You're really just graphing all the points that make the left side equal the right side. So if I have this point, I could plug it in and the left side will equal the right side. And this is an easy one to do because it just comes out to be 0. -3 plus 3 is 0. Well, 0 times 2 is 0. So that side will be 0. Y subtract, or 4 subtract 4 will be 0. So I get 0 equals 0. That will work for any point on the line. You plug that x and y value in into the equation, you will get the same number on both sides. So let's do that. It's sort of review stuff. We'll come back to that in a minute. So again, I'm going to kind of test the first one out for you, and then I want you to finish it off. So I'm going to say, okay, for this equation, really for this point, I'm going to start with the point. Is this point on that first line? So I'm going to go ahead and actually tell you what, I'll make it easier for you. I'll do the hard problem. In the other class, I did the easy one. I'm going to test it to see, is it on this line first? Is it on that line? Meaning, if I plug it in, does it make the left side equal the right side? So I just plug it in. Y is -2 plus 1. This is like when you did algebra, what did they call this? When you weren't talking about graphing lines, they just said, is this point on the line? Like it was just a verbal question. Is the point on the line? And you would just plug it in and see if it worked. So -1/3, 3 times, what is it? 3, and then subtract 6, and all that's in parentheses. So that's why I just plug in the x and the y. I put in -2 for y, I put in +3 for x, and now I just do the math. So 9 subtract 6 is 3. I'm just doing the math for you. 3 times -3 is -1. I didn't want it to work on the first one, but it's going to. So this over here then, -2 plus 1 is -1. So did I get the same thing to make the left side equal the right side? So that point is on this line. That's the one that matches up with that first one. Now, I didn't really want it to be the very first one. I just totally randomly got lucky. If it comes out to be any other numbers, like you get two different numbers, then you would just say, okay, that point is not on that line, and you got to try a different point or a different line. So I want you to try to figure out, you don't have to do every single one of them. Try to figure out where one of these points goes. You can either test one point in all three of those, or you can keep testing different points in the top equation, whatever you want to do, but find where one of the other points goes. Plug it in, figure out whether it makes the left side equal the right side. For those of you that are still getting called out to take the CLT and the ACT and all that, meaning you haven't graduated yet, this is the kind of stuff that's on the CLT. It's much more, I guess you could say, algebra sort of math, but it's not like super foreign concepts like some of the other tests that you take to try to meet your requirements. This kind of stuff will get you where you need to be on the CLT. Well, and I'm not saying this specific question, but this level of understanding. It's not always about like geometry and algebra 2 and that kind of stuff. The CLT is definitely more background knowledge, like math that you should know, math that they feel like you should know. Algebra, even the algebra EOC has some stuff on there that's, it's trickier math. This is not nearly as bad as some of that things. Is that holding anybody? What about that? I didn't do that. Has anybody gone this period? Oh, that is it. Yeah. I didn't. It wasn't shiny. So I mean, tape's not really my thing. All right, so I'll give you another minute. Hopefully by then you figured one out. But I do think this comes up at some point in a future lesson, but not really what we're doing today, or certainly not what you're on the answer tickets. We need to get you a notebook. Start getting on board with this. I'm gonna do that right now. Yeah, if you don't have a calculator, you'll need a calculator probably for the next part that we do. I want you to start taking notes on this and tell me about it. Leave it in here. Fifth period vascular. We don't always work straight through. Going back and finding notes if we randomly throughout the book. Raise your hand if you have at least one figured out yet. All right. Does anybody know somebody named Mariangeli Howard? Mari Howard, though, is like, because I know we have maybe one or two. I'm not sure.
I do not know the last.
Signed up for flag football, and I'm not sure if, like, you don't even have to be a student here to do that. So we're just trying to figure out, is she a student here, or is she just some random person that somehow picked our team? Well, this is not the school team. It's the city league.
Oh,
So, but it is most of them are our girls that go here, but really anybody could go in and pick our team and just sign up. So we're just trying to figure out, was she somebody here, or was she some just random person that just picked our teams? I can look it up later. I can just curious. All right. Now has anybody figured out one? Oh, come on. Why do you look like you're working? What are you doing? Not know how to do it? Like, did you figure out one, Andre? Okay, then it's not on. Well, then you just keep going. And once you plug it in, it doesn't work. Either take that same point and plug it into a different equation, or take a different point and plug it into the same equation. Either way will get you to where you need to go. Yeah, X comma Y, alphabetical order. Somebody figure it out so we can move on. I feel like we don't know what we're doing. But look like you're working frantically, so I can't tell if you're just trying to fake me out into it. Did you do it on the calculator, Troy? You're doing something. You're just playing on it.
I was trying.
We'll do it. Plug it in. You can do it on a calculator. I mean, I'll tell you the easy way now that I've kind of everybody's work. Pick a point, see if it works in that. And that's a pretty easy equation. So just keep picking different points. Don't move to the tougher equation. I mean, not that any of them are real tough. Just keep changing the points and not the equation. Stick with the same equation and just change which point you try. And again, that to me, that's an easy way to do it. None of them are. I did the toughest equation for you, so really, out of the other ones, none of these are equations. Well, you put it wherever it is. So you're not switching anything. If I'm testing it, the -4 is the y, so I put it where the y is. Or if I'm doing this one, I put it there. This one would be, if you're testing this one, this would be like, let's say I'm testing the second point. This would be -4 subtract 5 on the left. And then on the right, I would do 2 plus 7 and then times 3. So you're just plugging the number in. Once somebody hopefully figures it out, You're still working at it, I want to kind of do the work for you. You have one yet, Becky? You've been working and erasing and calculating, and you have one. So which one do you think is right? So let's test that one out. So Becky's telling us that it's this one and that one. So here's how we would do it. I'm going to test this one first. One she didn't think it was. So I'm going to test that one. That's my x and my y. I just plug them right into the equation. I'm going to write it above the equation, the same concept. So 2 is my x. So this is 4 times 2. Just plug it in, 2 for the x. And then I still have subtract 6. Was that a question, Troy? And then my y is -4. Now I just do the math. 8 subtract 6 is 2. So I get -4 equals 2. Is that right? Now make the left side equal the right side. Well, I plugged numbers in, but okay, let me ask it a different way. Did the left side equal the right side once I plugged numbers in? Is -4 equal to 2? No, -4 is not. I mean, that's positive number and negative number. How can they be equal? So that didn't work. When I plugged it, not for the top equation, that didn't work. So now we go to 0, 6, which is the one Becky says she thinks works. So I do the same. I just keep doing the same thing over and over. Question, David, or are you agreeing?
No.
Okay, let's do this one and we'll let you do that. So I plug in -6 for the y. So here's my y. I just plug it in for y. 4 times 0, subtract 6. I do the math, I get that. So did the left side equal the right side? -6 equals -6. So that is correct. So Becky was correct. This point here went with that point there. Which one do you think works for which, David? Oh, so you get that same one also. All right. I'm not going to keep doing them forever, but that again, that solves a lot of it. It's what a line is. A line is all the points that make the equation equal. I could pick an infinite number of points that would make the left side equal the right side. Like that's just one point, but I could pick an infinite number of points. Those points would basically be what my line was like. Like if I plotted all those points on a graph, that would be my line. It also answers the question that you'll get on some of the tests. It says, is this point on this line, or which point is on the line, or something like that. It answers that question also. That's how you do that if you see it on one of the other tests. All right, now we'll go back and do what we've kind of already did, but we did it really fast. So in your books, page 196. Page 196. Don't have your books, grab it. Page 196. Take some of these out. Email. Did somebody go and come back and? Oh, right here. Yeah, when they get back. So this is kind of blurry, so it's probably easier for you to look at your book. This covers two things. It covers one sort of lesson about creating equations. Oh, there you go, right there, I think. It also covers your exit ticket. Hurry back. The exit ticket's easy. I won't get to the exit ticket probably for about 3 or 4 minutes, so that should be fun. Here's the first thing we need to remember from stuff we've already done. It says, I want to create an equation that's parallel. What's true about line? So again, I kind of graphed it, I did it on my own just to sort of see, but parallel again, never going to touch, right? So if I have two lines that never touch, what is true about the slope of two lines that never touch? The slope tells us kind of like what angle is the line like. A flat slope or a low slope, like a fraction, means it's really flat. A high number means it's really steep. So what about two lines that are at the exact same angle, like they're never going to touch? What would have to be true about their slope? Well, they'd be parallel, but what would have to be true about the number part of their slope? If they're going to stay parallel and never touch, what would have to be true about their slope? What's the only way? Put it this way, if this slope is 2 and this slope is 1, it's going to be at a different angle, right? And eventually they would hit. They have to be the same. Because if they're a different number, then they're going to be going at different angles, and eventually they're going to hit someone. So the only way they can stay and never touch is if they're at the exact same angle, and that's kind of what the slope tells you. Like, what is the angle that the lines are going at? So, in order to create a parallel line, I already know my slope has to be the same. So I just use the slope that they already gave me. So we're going to create it in y equals mx plus b format. So first part of that, I'll write thicker so it's easier to see. Y equals negative 3/4 x, and then I still write the plus b. But that's not all we need. We want it to have all of the pieces, which means we need this b number. We need to know what that is. So what do we just say x and y are when it comes to lines? Like what do we just do in the problem before? The x and the y's or what? We said if that x and y makes the equation true, then what's true about that x and y? What's true about the point? We'll get to that. We'll get to this problem. I'm going kind of back to what we talked about. What is a line? Back to what a line is. It's all points. That's what I want. So the x's and y's are points on the line. Like that's what we just said when we said, okay, so therefore if we plug it in, it should make the left side equal. That's what it is. It makes the equation equal because they are points on the line. So if they give us a point and they say we want the line to have that point, that is a point that has to be on the line we're going to create. That x and y are what we're going to use for that x and y so that we can then solve for the y-intercept. So here's the process. So again, if you didn't completely understand that, here's the process. Just know that when you see a problem like this is what you do. We have the same slope. That came from the fact that we wanted it to be parallel. We need to use the point that they give us, which will be on the line. They tell us it needs to be on that line. That's what containing means. So we just plug those in. Y is 6, negative 3/4, and then we say times negative 3 is the x. And then we're solving for the y-intercept. That's the part that we need to create the equation. We don't know what that is, but now that we've created this equation using this x and y, we only have one variable. If we only have one variable, we can solve for that variable. So now we just do the algebra. In your calculators, do this. I just want you to see that it works. That your calculators will save you big time when it comes to this kind of stuff. Type in negative. Well, if you know how to do the negative, it's on the blue calculators, you do it first. On the white calculators, you actually have to do the number first. But however you do it, you're putting in negative 3, ABC button, and then the number 4, because that's the bottom part of the fraction. So on your calculator, you should see this, basically. Bless you. That is negative 3/4. That's how it looks on the calculator. Now we would say, okay, times, and then just negative 3. And what do you get? What's it show on the calculator? It should say 9 and then a little backwards L and then a 4. That's what you should see. If I multiply that, it should look like this. So you should see that on your calculator, 9 backwards L 4. If you don't see that, raise your hand. If you just hit equals, it'll simplify it, but that one is simplified. There's nothing else you can do to that.
Didn't come up with that.
It's the same 2 and then U and then okay. That's the same, which is fine. You can still use that.
Okay.
So if it doesn't show it as 9/4, this is the same number. Because if I divided 4 into 9, because 9/4 really means 9 divided by 4, I get this number that I'm about to show you. 1. Does it have a backwards L or does it actually have a slash? Which one? You have the blue one?
Yeah.
What about, does anybody have the white one? Does it show it like that or does it show it with the backwards L, 1 backwards L 4? Huh? Hey. But how would you get an 8? I have to look at what you do because it should come out with one of those other options. Regardless, though, all of these numbers are the same. You can work with that in what we're about to do. So here's the next step. When you could convert it to a decimal also in this one, it's pretty easy to do. Now, if I need to solve for B, I need to say, okay, I need to get rid of that 9/4 or the 2 and 1/4. So I need to say subtract 9/4 on this side, which means I got to say subtract 9/4 on that side, and then the B will be all by itself, and that'll be the value we use. So I subtracted 9/4 on the right. Well, whatever I do on one side, I have to do on the other side. So that went away. I have B all by itself on the right. 9 subtract that would be 3 3/4. So that is my y-intercept. So to finish off my equation, I add that into the end. 3 3/4. You might have gotten 15/4 possibly. So here's what I'll tell you. At the very least, just understand you have to have the same slope for parallel. On the exit ticket, that's all you need. Well, it's not a parallel line, it's perpendicular, but I don't have to do really anything about the y-intercept. You just have to know what to do to the slope, which I'll go over in a second for perpendicular. So, but that's the way you do the whole equation is you have to go through, solve for the y-intercept, solve for that b value, and you do that by creating the equation and then plugging in the x and the y from the point that they give you. There's another way to do it. I'm not even going to try to do it in this class. So I did it the other way in the other class, but the other way is no easier, so I don't see any reason to show you. It uses the point slope form, but it's the same math. It's actually one more step, so I'm not going to worry about showing it. All right. Again, you'll get practice on that. There's IXL where you'll be able to try to practice that more. So let's go ahead. Let me show you what's on the exit ticket. All right. So this is sort of like the exit ticket. The exit ticket's easier than just the first part. So same question that we just had. They give us a point. They want us to create the equation of a line. They don't say in slope-intercept form, but I'm just telling you to do it in slope-intercept form. So this is slope-intercept form, where the y is by itself. So we need to find the slope, and we need to find the y-intercept. Slope is all you have to do, really, on the exit. You just know how to come up. There's no math involved. It's just remembering how to do it. So if I want to create a perpendicular line, to this one right here. What do I need to do? Oh, I beat you that one. What do I need to do to the slope? What do I need to do to, it's not going to be the same slope, that's for parallel. What do I need to do to make it the perpendicular slope? So you think about that for a second. I want you to look back at notes, and I'm not going to tell you that. I believe we didn't do it for Bellworth today. It was your Bellworth yesterday or the day before, or maybe in a few different days. So look at your Bellworths and look for where we created perpendicular slope. Or just look for a perpendicular slope somewhere. We've done it many, many times. They want me to make you start looking using your notes and find it. They just take some time. That process. Two of them. Do that, and then we also do one other thing. Oh, no. It's the same word that you said. We do that word twice. I want you to think about it. Look through your notes. You got it. I know you got it. Let's walk around and see who has in their notes. Let's do that. So I can talk to parents about what you're not going to do. Right, D? So looking for it? In your bell words. Ooh, that doesn't like bell word. Holy cow. Huh? Oh, that's not just an app. See if you have any. Do you have just do an app? It's a lot easier to find. You got some blank bell words in that class. Man, maybe that's easier. I'm gonna have to talk to her. I'll be like, hey, I'm watching. It's a lot of your bell words. Well, that's if we have the two. That would be the test. We're trying to create. Oh, yeah. Yep. Like half an over TV. So you just oh wait, you did it. That was it. You didn't write what the original slope was. I said I'll just tell you the original slope on this. Oh wait, maybe I'm looking at the wrong one. Maybe it was yesterday. Oh, were you not here yesterday? Maybe you were testing yesterday. I think we actually did it yesterday. So I might have said Monday. This was yesterday. It was the second one yesterday. So look and see if you have the second one yesterday. We did the exact same thing yesterday.
Yeah, like
He wasn't here yesterday. He skips from the 4th to the 6th.
I think I got the date wrong. I think I put. I'm serious.
You did this. 10:30. What's today? What? Yeah, I don't.
Giant 1 page.
Like I did my notes, so that's what's different. And
Where's today?
Where's
today?
Oh, well, you have it written.
This,
That's not for your level. That's for let me see all your.
like look through them.
Yeah. Some of you have it, but you're not really labeling it, so. Go ahead.
Yeah, y'all might go get us. I know my word.
Yeah,
Half the minute was on.
You missed one, so that's what you need to correct that. You do this, but then you also do it. You're gonna show but they're not
Stuff like that.
Did you already see that? I'll say.
All right, now. You're in the closing. Okay, and you go, it's just like. The girl is crazy.
With this. It's whether you like it or not.
Sort of.
Right? It requires you to
But
be
you
on
don't.
that. And everybody.
You're like, you're not doing all that work.
You've done 9 years of tax.
Huh?
That's how it is. The problem right here. I'm going through it. I'm not even finding it, and we did it yesterday.
We should fix something right on that.
I want you to see this.
Do you have any more of those books, notebooks, composition books?
There's 3 up there, maybe just 2. I gave one away a little while.
You-
Yeah, that's for them. So yeah, if you found somebody that's not doing it. That's the problem when I walk around and not only did you not try to do it on your own, obviously, if it's not in your book, you didn't even write it down when I did it. That's an issue. Again, I'm not saying everybody, but I just went through like 5 people and nobody had it clearly labeled. A couple people had it and it wasn't very clearly labeled, but then 2 people didn't have it at all. That's the kind of stuff. Again, you guys have been pretty decent today, so I'm not writing any names on my list today. But on a day where you make me mad, that's what gets you on the list. When I walk around and stuff I have done on the board, I don't put bell work in there because it's not important. I put it as bell work because it's very important. You need to have that stuff in your notebook. So I'm going to do it again. You better have it in your notebook moving forward. If we need to create because this was on your quiz, so some of you maybe had it farther back, but you just had a quiz on this, so I imagine not many people did very well on that. It wasn't even in your notes at all. If you need to create a perpendicular slope, we take the original slope. So the original slope is the line that they give us, the equation already done for us. We say, well, the test, some of you did have this. The test is that I multiply 2 slopes together and I get -1. But we said in class, there's only one thing that will give us a negative number when we multiply, one situation. What is that situation? I have 2 numbers. There's only one way I can multiply them and get a negative number. One of them is negative, one of them is positive. That's the only way. 2 positives times each other obviously make a positive. But 2 negatives times each other also makes a positive. So we have to have one negative number and one positive number. That's it. No other way.
I would write that down and fold
Yeah,
letters.
some of you did have that sort of written down, but I would. So if I have positive 10/9 as my starting slope, my next slope has to be negative. So my perpendicular slope has to be negative. So we flip the sign is what we said in class. So to make a perpendicular slope, first thing you write is you flip the sign. If you want to write more than that, say positive changes to negative, negative changes to positive, whatever you need. But we flip the sign. Then we also flip the fraction. So if we start with 10/9, we make it 9. That's how you make it. There's no math. You're just memorizing how to do it. I mean, there is actually math you can do, but we're just going to memorize. That is the perpendicular slope. This is your exit thing, by the way. Just knowing that. Just being able to recognize when a slope is perpendicular. It is the opposite sign, and the numbers are flipped, And the last test that you could also just do on the exit ticket, multiply that together in your calculator. Hit 10. Then you like type in the number 10. ABC, that's kind of in the upper left, I think on both calculators. Cap ABC, I don't know. ABC and then 9. And it'll show you this in the calculator. This is how it shows a fraction on the screen. It shows that. That means 10 ninths.
times.
Then just the times button. Which calculator? You have the blue ones. Then on the blue ones, you hit the negative symbol now. If you have a white, then raise your hand if you have the white calculator. So on that one, you actually will -1. You will actually do, and that's the test for perpendicular if you get -1. So you'll actually on yours, you'll type in the number 9, then hit the negative. And on yours, the negative button on the white one looks like this. It's not a negative symbol, so for the white calculator that. But for the blue calculators, you then say times, you hit the little negative sign, parentheses, it's like in the lower left. Then you hit the number 9, ABC, and then 10, and hit equals. And you should get -1. When you multiply two slopes together, if you get -1, they are perpendicular. So that's how you know you created it correctly if you want to test it out. Yeah. So again, creating it, you can just flip the sign and flip it upside down. To test it, you multiply both of them together and see if you get -1. Don't get it. So ABC 9 is for 4 times. Oh, no, you would do the number first on this. On the blue ones, you do the symbol first. Times. And we now type in 9 and then ABC. Yeah, the white ones and blue ones work differently. I think one's more of a like that's a scientific calculator. I don't know what the blue. All right, so now the rest of this is we do the same thing we did in the last one, but that's all you need to know really for the exiting. You just need to be able to, and it's multiple choice, so you really just have to be able to identify which one has the perpendicular slope, and there should only be one, I'm pretty sure. I don't think you even have to know how to do the rest of what we're about to do. So now using that, we're going to go ahead and go through the rest of the process. This is straight from IXL if you didn't notice. So this is how IXL looks. I'm pretty sure this is IXL VEB. So that's the one I'll be pulling your questions from for the quiz next week for this topic. Wait. Yeah, next week because next week. So VEB. It is exactly like what's going to be on the quiz, what we're doing right now. So my equation then, the next step is I write the equation with all variables in it, except for that -9/10. So that's slope-intercept form. Now, I need to solve for the y-intercept. That's the piece that I'm missing. I have an x and a y. They give that to me right here. So I plug those two numbers in for the x and the y. That's a 3, -9/10. My x is -3. And then you solve for b. So I'll let you try to do that. Yeah. Did you guys already do your thing this morning? Isabella, I'm sure. Yeah, Isabella. So again, 90% of what we do in this class is algebra. I think this class is super hard is because we don't really have great recall on our algebra. This is certainly algebra here. Actually, this whole lesson is really algebra. So I'm going to go ahead and kind of get started. You guys can Do it kind of in your calculators. I'm going to do it. Just check my math. Because this does get into some. This is why I say knowing how to use that you see the kind of fractions we're getting into on this. Knowing how to use that ABC button is a lifesaver because the EOC and the district stuff, they aren't scared to put fractions in problems. I don't really do it as much. They will do it a lot. But if you know how to use the fraction button, it's just like doing any other problem. So again, if they give you three numbers, basically the first number is the whole number, and the second two numbers make up the function.
27 over 10. Because two.
So again, how are they getting that? You tell me. How you have the correct answer, I have the correct answer. I'm combining them, and that just is that's a coincidence because there's a 10 down here. If it wasn't a 10, it wouldn't count. What do you do with a fraction to make it a mixed again? This is old math. It's like elementary school math. What's the other way to show a fraction besides the number on top being bigger? Well, we could do that, but I want to show it as a fraction. Let's go over this. I didn't do this in any of the class, but it drives me crazy when we don't remember like elementary school because we never ever use it. Like you literally just rely on other calculators, everything else. So that's what it's called. So we need it. This is I don't even know. This is an improper fraction. They call that. Then there's something that's called a mixed number. What is a mixed number involved? What's so a whole number. We need to figure out how many holes do we have? Like what's the think of pizzas. How many whole pizzas would we have if we had 27 pieces and each pizza is going to have 10 slices in it? How many whole pizzas could we make? That's what you're doing. We could make 2 whole pizzas, right? I'm just going to do it over here. So I could make 2 whole pizzas. So they would both have 10 slices each. And what would I be left over? That's what they're showing you on the graph. Same number, just as a mixed fraction instead of an improper fraction.
So if I put that in.
It'll work. Both of them work. Both of them. Now, on a quiz, like on an EOC or something, they may show the answers in one certain way, and you have to understand that they're the same number and be able to convert it back and forth. They may show the number as this, but your calculator might give you that, or the other way around. They may show it as that, and your calculator might give, because sometimes the calculator will give you that, but not the other. About how it's set up. Now to solve for B, we just subtract. Subtract 27 tenths or subtract 2 and 7 tenths. So subtract that, and you should get B equals 3 tenths. There we got. Everybody do the whole thing. So B equals 3 tenths, which means my equation for the line that is perpendicular to that, I'm just going to rewrite it. Y equals, we flip the fraction and flip the sign for the perpendicular slope. X plus, I think that was right, 3/7. Yeah, 3/7. So that would be your equation. Again, for the exit ticket, all you really have to know how to do though is just change the original slope to the perpendicular slope. I give you a full equation, but if you look through all the slopes, there will only be one that is the correct. So in your calculator, if you do 3, subtract 27 tenths, I just subtracted. Because I need to get this is the y-intercept, right? Mm-hmm. So I need to get that by itself. So to get it by itself, I have to get rid of that. So I subtract it. Just get out the algebra and solve for it. That makes sense? All right, this is an IXL you're gonna have practice. I'm not gonna keep doing more problems. Again, IXL VEB, that'll be your next quiz. And I'll probably also repeat one of the things that was on your last quiz that we did really quick, like maybe graphing a perpendicular line. So they're kind of similar. And there'll be a couple of these. One will be creating a parallel line. One will be creating a perpendicular line. You'll see that twice. So make sure you practice it. Not too bad. at the very least, you should be able to give me the correct slope. The only part that's a little tricky is figuring out the y-intercept for the B part. No, it's not. I mean, that's not 20 minutes. So here's what I will tell you to do. I'm not going to have you do IXLs. Go to your book page. This is still the same, page 196. I believe it starts on problem 22. If you try to do what we just did from the book problems, at the very least, do the ones that say perpendicular and just try to change the slope part. Even if you don't get all the rest of it and have to create the whole equation, go through and make it the correct slopes. Call me over and I'll check and make sure you're getting them right, and then you'll know you're good for the exit. But at the very least, just go through all of them that say make it, make a perpendicular equation or whatever it says. Just try to at least change the slope part. If you can do the whole equation and solve for the B, then do it. But that's something you can also practice with IXLs, where you can, if you miss it, it'll walk you through how to do it and you can get more help. So page 196, I'm pretty sure it starts at number 22. It's whatever section says example 5. That's the example we just did. 198. 198? Is it really? All right, 198. Oh, yeah, because the practice problems don't start until 196. I went one page before it, but it's one page after it. Yeah, 198, I'm sorry.
So when I did that, but
What did I write?
3/7.
Oh, did I really?
Yeah.
Oh, I did. Right, you're right. Yeah, I'm sorry. That's just me writing my thing. So yeah, the answer, if you're confused, thank you for saying that. 3/10. So 3 subtract 27/10 would be 3/10, not 3. I don't know where I got 3. So yeah, if you were confused by that, that was just a typo. I just totally was just thinking one thing and wrote down wrong. Like I said, there's at least, I guess, saw maybe 3, yeah, so I guess they're actually. So I think there's at least 3 that say create the perpendicular line. Go to those and at least do what we did with the slope. Change the slope value to the perpendicular slope. Call me over, let me check it so that I know that you're good for the exit. Easy exit. If you do that. How many of them are there?
4.
Just 2. Okay, so there's only 2, I guess.
I got here. So,
Well, then you'd have to create the slope and everything. I mean, you could do that. Oh no, that's much worse. Well, I wouldn't be surprised if they do that on the EOC, but we're not going to even try that. Do that, I'd be crap. So that would be the perpendicular. Yep. And technically, that's just negative 2. But I don't think
I can't understand the number.
no, one more. You're missing one thing for that, though. What do you need to do on that? Yeah, you do both. Don't forget to do both. So that 8 has nothing to do with the slope.
I used to get school.
I didn't hear.
nice.
Sometimes I hear things. Whoa. Sometimes kids will like accidentally tap their desk or the board or something. I think it's the door. So I walk out there all the time. Let's see. Oh boy, a lot of you are messing up. Oh, actually, this one's correct. That's the one. What sign is this? There you go. Remember, you have to flip the sign and flip the fraction. No, if you didn't flip the fraction, that's just
You just change at the time.
So what do we say we have to do? When it's non-fraction, you do what? Make it a fraction.
I gotta get
Figure out how to make it a fraction and then. Oh, there we go. Now we find it's 1, negative plus 1. So yeah,
I get it.
yeah.
You're somewhere, right?
So you should know how to, all you do is change like sign, that's the slope. Others with the X. That's the slope.